Have you ever pulled up to a red light completely relaxed, only for your vehicle to suddenly start violently shaking, vibrating the steering wheel right out of your hands and watching the RPM needle bounce wildly up and down like a metronome? Or even worse, you try to pull out into fast-moving highway traffic, you step confidently on the gas pedal, and the car just completely ignores you for 2 terrifying seconds before suddenly jerking forward with aggressive force. Most drivers immediately panic when this happens. They assume the automatic transmission is completely destroyed, the internal engine components are dying, and they are about to face a massive, wallet-crushing repair bill at the local dealership. But before you call a tow truck in a panic or hand your keys over to a service advisor, you need to know about a tiny piece of plastic and electronics hidden under your hood that is notorious for causing all of these terrifying drivability symptoms. Today, we are going to completely demystify the electronic throttle control system, specifically focusing on the throttle position sensor, and I will show you exactly how to fix these massive engine issues right in your own driveway without spending a dime on unnecessary repairs. To truly fix the problem, you have to understand what is actually happening under the hood when you press the gas pedal. In older classic cars, your gas pedal was physically connected to the engine intake with a brace steel cable. When you press the pedal with your foot, it physically pulled that cable and manually ripped a metal flap open to let fresh air into the intake manifold. It was a simple mechanical connection. But modern vehicles abandon that completely and use a complex drive-by-wire system. There is absolutely no physical connection between your foot and the engine anymore. Your gas pedal is essentially a highly sensitive video game controller. When you press it, a sensor down by your foot sends a rapid electrical signal to the vehicle's main engine control module. The computer heavily processes that request, calculates the current emissions data and fuel mapping algorithms, and then commands an electric motor located on the throttle body to physically open the internal butterfly valve. Sitting right on the side of that valve is the throttle position sensor. Its entire job is to constantly report the exact physical angle of that metal flap back to the main computer. It is a continuous, high-speed feedback loop happening thousands of times every single second. But when that delicate communication loop gets interrupted, your engine completely loses its mind. When the throttle position sensor loses its factory calibration or gets physically blocked, the engine computer gets completely blinded. It no longer knows exactly how much air is entering the intake manifold. Because the computer cannot calculate the incoming air volume, it has absolutely no idea how much liquid fuel to inject into the cylinders. This massive data failure results in the classic symptoms you feel in the driver's seat. You get the erratic, surging idle where the engine aggressively revs up and down entirely on its own while you are sitting in park. You experience incredibly heavy hesitation and a dangerous dead zone when you try to accelerate from a dead stop. And the absolute most dangerous symptom of all, random engine stalling in heavy stop-and-go traffic. The vehicle computer essentially goes into a protective panic mode, heavily reducing overall engine power to prevent catastrophic internal damage. You might even see a wrench icon or a bright yellow check engine light illuminate on the dashboard. But do not let the flashing lights scare you, because the mechanical fix is usually incredibly straightforward and requires very little technical experience. We have to start with the physical mechanics before we even think about touching the digital electronics. The most common reason a throttle position sensor loses its baseline calibration is actually heavy physical dirt buildup inside the intake tract. Your engine naturally produces hot, oily, blowy gases from the pressurized crankcase, which are specifically routed right back into the intake manifold to be burned off for emissions purposes. Over tens of thousands of miles, those hot oil vapors bake onto the back of the metal throttle body flap, creating an incredibly thick, sticky ring of black carbon sludge. This heavy sludge literally prevents the metal flap from closing completely to its factory resting point. The computer tries to command a closed idle position, but the throttle position sensor reports that the valve is still slightly open due to the hard dirt block. The computer gets confused by the conflicting data and starts violently adjusting the idle speed, causing that awful shaking and stalling. To fix this underlying root cause, you do not need an expensive mechanic. Just disconnect the negative battery terminal for ultimate electrical safety, pop off the black plastic air intake hose connected to the engine, and look deeply inside the aluminum throttle body. Take a clean microfiber towel, spray a dedicated throttle body cleaner solvent directly onto the towel. Never spray it straight into the sensitive electronics. And carefully wipe away that thick black ring of carbon. You can gently push the metal flap open with your fingers to clean the edges, but never let it violently snap shut. You want to see shiny, clean aluminum all the way around the internal bore where the flap normally rests. Just taking 15 minutes to wipe away years of baked-on engine grime will instantly restore the factory airflow dynamics and give the sensor a clean slate to work with. If you are finding this deep dive into your engine's electronic brain helpful and you want to keep your ride running flawlessly while avoiding those massive mechanic bills, take a quick second to hit that subscribe button. We share heavy-duty, real-world automotive engineering knowledge here, and having you as part of our garage community means a lot. Let us get back to resetting the system. Once the physical dirt is completely gone, the electric sensor is still going to be highly confused because it has slowly adapted its memory to the dirty, clogged environment over the last several years. You have to force the engine computer to relearn the newly cleaned baseline. One of the greatest diagnostic secrets master mechanics use is the manual pedal relearn procedure, which requires absolutely zero specialized tools. Get into the driver's seat, close the door, and turn the ignition key to the on position so all your dashboard lights illuminate, but do not actually start the engine. Now press the gas pedal down to the floor very smoothly over a period of 3 seconds. Hold it pinned firmly to the floor mat for exactly 3 seconds. Then release it smoothly over another 3 seconds. Repeat this exact pedal motion 3 times in a row. What you are doing is manually sweeping the throttle position sensor through its entire electrical voltage range, forcing the main computer to register the absolute 0 point and the wide-open throttle point. Once you finish the 3rd sweep, leave the key in the on position for about 30 seconds so the computer permanently saves the new parameters into its long-term memory bank. Turn the key completely off, then immediately start the engine and let it idle and park for 5 solid minutes without touching the gas pedal. In a massive amount of cases, this simple pedal dance completely cures the hesitation and stops the surging idle dead in its tracks. If the manual pedal dance did not completely smooth out the engine idle, you need to escalate the repair to a full hard reset of the engine control module. This is the exact mechanical equivalent of pulling the power cord out of the wall on a completely frozen desktop computer. When an engine runs with a dirty throttle body for a very long time, the computer builds up heavy, long-term fuel trim adaptations that get deeply stuck in its memory. To wipe that memory completely clean, you need to disconnect the vehicle from its main power source entirely. Make sure the keys are completely out of the ignition and sitting in your pocket. Take a standard wrench and completely remove the negative black battery cable from the battery terminal post. Now, you have to exercise extreme patience. Walk away from the vehicle for at least 10 to 15 minutes. The engine computer has large internal capacitors that hold a backup electrical charge, and it takes significant time for that residual electricity to completely drain out and wipe the volatile memory banks clean. After 15 long minutes have passed, reconnect the negative terminal and tighten the nut down securely. Turn the key to the on position for 30 seconds without cranking the engine, allowing the throttle body motor to electronically buzz and physically align itself in the engine bay. Then start the car and let it idle. The computer is now starting from a total blank slate, relearning the perfect fuel ratios for your freshly cleaned intake system from scratch. While you are waiting for that battery to drain its residual power, it is the absolute perfect time to look for another silent automotive killer that mimics a failing throttle position sensor almost perfectly: a major vacuum leak. The throttle body precisely controls the air entering the engine, but if there is a massive crack in the rubber intake boot right behind the sensor, or a split in one of the tiny vacuum hoses running along the plastic intake manifold, unmetered atmospheric air is bypassing the sensor entirely. The computer is desperately trying to balance the idle using the throttle flap, but it cannot account for the secret air leaking through a dry, rotted rubber hose. Take a bright flashlight and physically squeeze and bend the thick rubber accordion hose connecting the plastic air filter box to the metal throttle body. Look very deeply into the folded pleats of the rubber. If you see any dry rotting, cracking, or severe tearing, that is your hidden culprit. The engine is literally sucking in excess outside air through that tear, causing an extreme lean running condition and the violent shaking at red lights. Replacing a cracked rubber intake boot is incredibly cheap and will instantly stabilize a wandering erratic idle. Now, what happens if you have tried all the manual resets, you clean the metal flap until it shines, but there is still a bright yellow check engine light staring you aggressively in the face? That glowing light changes the diagnostic game entirely. If the computer has triggered a hard fault code specifically for the throttle position sensor circuit, the manual pedal dance simply will not work. The computer has locked itself into a heavy fail-safe mode to protect the drivetrain from self-destruction. You have to use modern technology to fight modern technology. You need to plug an OBD2 diagnostic scanner directly into the data port located right under your steering column. Once the scanner securely connects to the engine computer, you want to navigate through the digital menus looking for a specific service function usually called a throttle relearn, idle air volume learning, or a TPS reset. Every scanner manufacturer calls it something slightly different depending on the vehicle brand. When you initiate this digital command, the scanner bypasses the factory safety lockouts and forces the throttle motor to manually sweep the flap, closed and open, permanently overwriting the stored error code with fresh, highly accurate calibration data. Follow the on-screen prompts exactly as they appear on the tool, clear the check engine fault codes, and the vehicle will instantly exit limp mode and restore full factory engine power. The absolute best automotive technicians in the world do not just fix broken cars when they roll into the shop. They proactively prevent the cars from breaking down in the first place. You should never wait for your engine to start violently stalling in the middle of a busy intersection before you decide to care about the complex throttle system. Make this cleaning procedure a permanent, non-negotiable part of your long-term vehicle maintenance routine. Every 60,000 to 100,000 miles, depending heavily on how much aggressive stop-and-go city driving you do, take the rubber intake hose off and physically clean that throttle flap. Keep that heavy carbon ring from building up, and the throttle position sensor will never lose its vital baseline calibration. It is a simple, highly satisfying weekend project that ensures your engine breathes perfectly and responds aggressively the exact second your foot touches the accelerator pedal. By staying proactive and ahead of the inevitable carbon buildup, you maintain razor-sharp throttle response, maximize your long-term fuel efficiency, and completely avoid the absolute nightmare of a dead car blocking traffic. You are now heavily armed with the exact diagnostic steps and mechanical secrets to conquer one of the most frustrating and misunderstood drivability issues in modern vehicle. If this deep mechanical breakdown helped you understand your complex machine better and saved you an incredibly expensive trip to the local repair shop, the best way to support the channel is to hit that subscribe button for more hardcore automotive engineering tips. Drop a comment below with your own garage success stories and let us know what massive repairs you have tackled in your own driveway. Share your mechanical wins so the whole community can learn and stop relying on expensive dealerships. Keep your intake completely clean, respect the machinery, drive safe, and I will catch you in the next one.